Alright, you're welcome to this lesson, and in this video we shall be discussing derivatives, and this is our first lesson on derivative, and you're welcome as you join us. So what is derivative to begin with? The derivative of a function is a function that gives us the slope of a tangent line of some other function or of some original function. Now, what I will come again, I will say that again, that a derivative is a function that gives us the slope of a tangent line of some other function. That is actually the basic definition of derivative. And what do we mean by this? What do we mean by giving us the slope of a tangent line? Now, take a look at our xy plane. If we have our xy plane like this, pardon my graph, our y plane and our x plane, and we have some functions in this manner. Let's say we have y equals x squared. At x equals 0, we get y0. At x equals 1, we get y1. At x equals 2, we get y4. So this graph picks up like this. Now this graph is not drawn perfectly, but let us assume that this is this graph. Now let us just assume already that we want to find the slope of this line. We can find the slope of this line using the secant formula, and the secant formula that we know is the secant formula is equal to our y2 minus y1 all over x2 minus x1. Why do we have our secant formula? This is because your secant line is the line that touches a curve at exactly 2 points. Now, whenever we want to find the slope of a line, what do? What we do is we pick any 2 points. We pick any 2 points on that graph, and we link them up, making this our y1, this man our y2, this our x1, and this our x2. This is how we get this formula. This is because this line, we have 2 points here touching this line. What is a tangent line? A tangent line is a line that touches this curve at exactly 1 point. That is, I can have my point like this, and I will have my tangent line like this. No, not touching any other point except this one. Now this is my tangent line, and these are my secant point. Now that is the difference between your tangent line and your secant line. A tangent line is a line that touches a curve at exactly 2 points, while a tangent line is a line that touches a curve at exactly 1 point. Now this you are seeing here is the slope of a secant line. Now, when we are asked, according to our definition, we said the derivative is a function that gives us the slope, that gives us the what? The slope of a tangent line of some original function. Now let us assume that this is our function y equals x squared. What is actually what we mean by the word derivative? Now imagine you are in a car and you are traveling at different speed. You can run fast, you can run slow. Now the rate at which you change that speed is what we call the rate of change. Now that rate of change is what we call the derivative. Now imagine that at an instant of time, most time we represent our x with time and our y with our distance. Now at an instant of time, we may be asked to find the slope of this function at this point. That's what we mean by that definition, that the derivative of is a function that gives us the slope of a tangent line of some original function. Now, like I said before, a tangent line is a line that touches a curve at exactly one point. Now you are asked to find the slope of a line at exactly this point. That is the instantaneous rate of change at exactly this time xt. This time xt. Now what do we do? What did we do to find that? To find that is just simply differentiating your function at that man, that is f prime of x at, let's assume this time here is 2. Let's assume your time, let's put it as 2. At 2. That is what will give us our results here. Now let us solve this man and see what we get. Now our m tan for this man, to differentiate this, there's a power rule you have to know at this point, and that power rule says that if you want to differentiate something like x squared, all you have or a basic formula xn, all you have to do is bring this value down, multiply it by your variable, and deduct 1 from the power. So that becomes y prime of x, or f prime of x, is equal n by x is nx, then n minus 1. This is a basic rule, and we call it the power rule, and this is only applicable whenever you have a variable to a constant problem. And just like we have here a variable to a constant problem, we can apply that, and when we apply that, we multiply 2 by x, and we get 2x, and 2 minus 1 gives us 1. That gives us 2x. And at x equals 2, we have 2 into 2 and is equal to 4. Are you seeing that now? Which means that but according to our definition that says that the derivative is a function that gives us the slope of a tangent line of some original function, which means that this is our function, this is our derivative that gives us the slope of the tangent line at the point 2. Yes, that is what we actually mean. Now the idea here is that how can we approximate the secant line? How can we approximate the secant line so that it moves so close and closer to the tangent line, so they are the same? Yes, that is the goal. The goal here is can we move closer and closer from both sides? Remember the idea of limit. Can we move closer from the left and from the right? Can we move close to 2 from the left and right from this side, so that our secant line will be equal or almost equal to our m tan? That is the idea here, that can we move so close to this point so that our secant line will be the same as our tangent line. Yes, that is the point. Now let us see. Now we are assuming that this point here is where we have our point 2. Now to use your secant formula, which is the y2 minus y1 all over x2 minus x1, all you have to do is pick 2 points so that the point you already have is in between those 2 points, and when you find the average of those 2 points, the result must give you 2. Yes, I'll come again. All you have to do here to use this to approximate this is that you have to pick 2 points such that the center you have is in between those 2 points, and make sure that those 2 points you are picking are close enough to 2 so that we can use that to approximate our secant line. So now in this case now, what can we use? Yes, what can we use? Okay, what can we use? Now this is 2 here. What if we use 1.9? We can use 1.9 1.9 and 2.1. Yes, 1.9 is 2.1. 1.9 and 2.9. When you add those top, you get 4. 4 divided by 2 will give you 2. So that point is enough. So we can use 1.9 and 2.1. 2.1. Yes. 1.9 and 2.1. Okay, now when you, this will be your x1 and this will be your x2. To use this to approximate, we have, you have your msec will be equals to, the formula you add was y2 minus y1 all over x2 minus x1. Now this is your y2 will become f of y2, y1 becomes f of y1 all over x2 minus x1. Now your y2 is 2.1 squared. Yes, your y2 is 2.1 squared, is 2.1 is 2.1 squared, while your y1 is 1.9 squared. Is 1.9 squared all over 2.1 minus 1.9. If you do this, the answer you get will be 4. Before you see how will be approximately or equal to 4. You see how we have been able to use our secant line to approximate our tangent line by picking value so closer and closer to 2. Now 1.9 and 2.1 gave us the average of 4. 1 and 3 will also give us the same thing, but if you observe, 1 is far from 3, 1 is far from 2, and the 3 is also far from 2. So if you pick any two numbers such that when you find the average, it gives you 2, those two numbers will have different distance away from 2, and they will give you different results. So trust me, pick two numbers very close to 2 from either side and use the secant line. That will be a good approximation of the tangent line. Now this is a secant idea. There is another idea that we can use to solve this problem. Now mind you, we have been saying that we can pick two numbers from the right and left, so that when we put those two numbers here, it will approximate to our tangent result. Now we can also apply the limit problem, and the limit formula says that the limit as x is approaching our value c, of f of x minus f of c all over x minus c. This is a limit formula that you can apply. Now let us apply this and see what we get. Now, what is f of x? F of x is your function, which is your x squared minus, what is your f of c? Our f of c is by putting c as 2 in the equation, which will give us what? 2 squared, which is 4 all over x minus 2. Now this is difference of 2 squared, and our x is approaching what value here? 2. If I apply 2 here, this man becomes undefined, so I have to use difference of 2 squared to open up this numerator so I can see where I'm headed. So by the formula of difference of 2 squared, here we give us x minus 2 and x plus 2 all over x minus 2. Now this can cancel out this, and we have x plus 2 left. If I put my limit as 2 here, we have 2 plus 2 is equal to 4. Now this tells you that you can apply limit and you can use your secant line equation and your tangent line, and this will still give you the same result. Now this is the idea behind derivative. Derivative just tells you how much you are traveling in line, how much you are changing, how much you are running slowly, how much you are running fastly, how are you going in a closer direction, are you increasing, are you decreasing. That is the idea about derivative. While integral tells you the total accumulation of what you have done in all those directions. Thank you, and see you in the next video where we explore more on this concept. See you. Please don't forget to like and subscribe.